Assalamu alaikum. In the middle of 18th century, a scientist by name Fizeau performed an experiment to determine the velocity of light in air. In this video, we'll discuss this method followed by him to get the velocity of light in air. First, we'll discuss the experimental arrangement. He took a source of light. Let me represent by letter S. A ray of light from the source is made to fall on a glass plate. This glass plate is inclined at an angle of 45 degree and it is partially silvered. Here the angle between incident ray and the glass plate is nothing but 45 degree. Now after reflection, the ray of light travels perpendicular to the incident ray and made to pass through a wheel. Now, we kept one wheel here. This wheel is provided with a number of teeth and cuts. These are teeth. These teeth have cuts on both sides. So this wheel had a teeth separated by cut of a same length. Okay, I'm just drawing it approximately this manner. Okay, now when light passes through one cut, it falls on a mirror. Now, let me increase the distance. I have increased the length further. Now, here a plain mirror was placed, which is denoted by letter M. Here the distance between the wheel, tooth wheel and the mirror is nothing but D. That is represented as letter D. This is the distance between mirror, plain mirror and the tooth wheel. Okay. Here this wheel is rotated with the help of a mechanical arrangement, which is not shown in this diagram. Okay. Now what happened actually? The reflected ray is made to pass through a cut through this tooth wheel and made to fall on this mirror. Once it fall on the mirror, it gets reflected back. Earlier it was moving this way. Then after some time, this gets reflected. This reflected ray pass through the same cut. If the wheel is not rotating, then it falls on this glass plate G, inclined at an angle of 45 degree, and this time it passes through it. Okay, and viewed by an observer. Now suppose this is the eye of the observer. Then in this case, it is viewed. Fine. This is the experimental setup. Now, what is done? He made this wheel to rotate in such a way that the reflected ray can pass through one cut, and when the light returns after reflection from the mirror M. It is allowed to hit the tooth which is present next to the cut which is through which it has passed earlier. So in that way, the speed of this wheel is adjusted. Clear? So by doing so, what happens? Yeah, suppose I take this as the center of this wheel. Here, suppose this is the line which connects the tooth to the center. Now, if I draw a line from the center of the next cut, then the angle between these two is taken as theta. So here theta is the angle between first tooth and the next cut. Clear? Okay. Now here the velocity with which the light is traveling is found very easily. Here we know velocity is nothing but rate of change of a displacement. Displacement divided by time is the velocity. Here the distance traveled by light is taken as twice of the distance between a wheel and the mirror. That is 2D. Here 2D is the distance traveled by light from the wheel to the mirror and back. Now, when it is divided by time, we get the velocity of the light. Understand? Then after that, here, let me find out the value of t. To get the value of t, we must know the angular velocity. By knowing the angular velocity, the value of t can be obtained. What is angular velocity? Angular velocity tells us to what extent an object is rotating. Okay, and is represented omega, and we know angular velocity omega is obtained or taken as rate of change of angular displacement. Here theta is the angular displacement and t is the time. So omega is taken as theta upon t. Theta upon t. Fine. Now already I have shown you how to get the value of theta. Here theta is the angle between a tooth and the cut beside it. Now before going at, let me tell you something about the distance between the toothed wheel and the mirror. The distance between the toothed wheel and the mirror, which is represented by letter D, it is found to be equal to 8 kilometer. It was kept as 8 kilometer. No, it's a very large distance. Now, here, theta is the angle between a tooth and the cut, is found to be equal to the ratio of total angle. The total angle of the wheel, the rotating wheel, divided by number of teeth plus number of cuts. Okay, this ratio gives us the angle theta. Okay, and here what is the total angle of the rotating wheel? We know Here this wheel is circular in shape. Okay, any circle have an angle of 360 degree. Okay, in radian this can be represented as 2 pi. Here pi is 180 degree, so 2 pi is 360 degree. So the total angle of the circular wheel is nothing but 360 degree. It's divided by number of teeth. Here I say that it has got n number of teeth, and n number of cuts. These both are same. So what do you obtain? Here theta is found to be 2 pi upon 2n. Here 2 and 2 get cancelled, and we get the value of theta to be equal to pi upon n. Okay, I just box this. So that it can be used later stage. Okay, later stage. Now here we have the value of theta and we know the value of v. Okay, and also we have the equation that gives the angular velocity omega. Now I am going to use theta, the value of theta in this equation. Substituting theta value in the equation of omega. So in this equation, I am going to use this one. Yeah. So what I am going to do? So omega. So theta upon t, in the place of theta, I write pi upon n. Yeah, all is divided by t. The next step, let's see what I get. Look at this carefully. Omega is kept as such. Here pi by n is written in numerator, then t is also taken to the numerator. So when it is taken to the numerator, it will appear as 1 upon t. So next step, omega value is found to become equal to pi upon n t. This is the value of omega. Now from this equation, I am going to get the value of t. So this can be done by cross multiplication. I am going to take a t that side, so omega will come down to denominator. So t is taken to this side, automatically omega will come down, pi upon n omega. Right? This is what found here. Okay, this is the value of t. I am going to use this here in this equation. For better understanding, I name this one as equation number 1. This is as equation number 2. Now I substitute equation number 2 in 1. See what we get if we do so. Here v value is going to be equal to 2d. Here d is the distance between mirror and the toothed wheel. Okay, so 2d is the twice of the distance between these two. It is the distance traveled by light between mirror and the toothed wheel to and fro. Okay. Okay. Now here equals to 2d upon pi divided by n omega. Okay. The next step, 2d is kept here as such, and it is taken to the numerator. So what will happen when I take a pi upon n omega to numerator? It becomes n omega divided by pi. Fine. Yeah. So rearrange this one as n omega 2d upon pi. This is the final expression I get, which represents the velocity of light in a air. Okay. Here, while performing this experiment, Fizeau find it a little difficult to visualize the light, the disappearance of light when it hits the tooth after getting reflected from the mirror. That is the biggest thing. This is the biggest difficulty he found while performing this experiment. Now, the velocity of light that he obtained was very close to the velocity of light which is known to us. We know the velocity of light now is taken as the c, which is equal to 3 into 10 power 8 meter per second. This is the velocity of light in air. And here, after some time, with the help of sophisticated arrangement, the same experiment was performed by other people, and they found that the velocity of light obtained using this method is nothing but 2.997 into 10 power 8 meter per second. You can see this value is very close to the original value of velocity of a light. Now, this is the method followed by Fizeau to determine the velocity of light in air. Before conclusion, let me explain the experimental setup once. Here, what he did, a ray of light from a source is made to fall on a glass plate which is inclined at an angle of 45 degrees. Then this ray of light gets reflected and passes through a cut present in a toothed wheel and made to fall on a mirror which is kept at a distance of d from the toothed wheel. Here, the distance between toothed wheel and the mirror was kept as 8 kilometer. Okay. Now, if the reflected ray returns after reflection, the reflected ray find that this wheel is at rest, then it passes through the same cut and reaches the observer. But here, the angular velocity of this wheel is adjusted in such a way that the reflected ray can be blocked by the tooth present next to the cut through which it was passed earlier. Okay, so by doing so, the velocity of light is obtained with the help of this equation. I hope the video is useful. If you have any doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.